Hey everyone, and welcome. Today, we're diving into a really complex and honestly often misunderstood disease, lupus. But here's the thing, this isn't just a story about the problem, it's about the solution. We are living through an absolute revolution in how we fight this illness, moving from old-school brute force tactics to incredibly smart precision weapons.
Just think about that for a second. The very system that's designed to protect you, your immune system, gets its wires crossed and launches a full-scale attack against your own healthy cells, your own organs. This is the day-to-day reality for millions of people with autoimmune diseases like lupus. It's literally a civil war happening inside their own bodies.
So, to really get why these new solutions are such a game changer, we first have to understand the nature of this internal conflict, this civil war, and why it's been so unbelievably hard to treat for so long.
Okay, so lupus, or SLE, it all comes down to what's called a loss of immune tolerance. In simple terms, the body's defenders can't tell the difference between friend and foe anymore. They start churning out these rogue proteins called autoantibodies that target the body's own tissues. And this just creates a vicious cycle of inflammation and damage that can hit almost anywhere: the skin, joints, kidneys, even the brain.
For decades, the main goal was just to stop the fighting at any cost. So doctors reached for these powerful, broad immunosuppressants like steroids. The best way to think of these is as a sledgehammer. Yeah, they're great at knocking down inflammation fast, but they cause a ton of collateral damage along the way. We're talking infections, organ damage, heart problems. It created this awful choice for doctors and patients.
And here's the kicker. Even with those powerful sledgehammer drugs, the results were, well, not great. A huge international study recently found that only about half of all lupus patients ever get to remission or even what's considered low disease activity. 50%. I mean, that number just screams at you, right? It shows how desperately we needed something better, something smarter.
And that, right there, brings us to the exciting part of the story. Over the last decade or so, science has started delivering those smarter weapons. Therapies that are designed not just to crush the immune system, but to intelligently guide it.
This is the concept that changes everything: targeted therapy. So if steroids are the sledgehammer, these new treatments are like scalpels, or even better, like precision-guided missiles. Instead of just carpet bombing the entire immune system, they're built to hit very specific targets, individual proteins or cell pathways that are actually driving the attack. The goal is simple: maximum impact on the disease with minimum collateral damage.
Let's look at the first two big game changers that got approved. First up, belimumab. It goes after a protein called BAFF. Think of BAFF as a survival signal for those rogue B cells that make the autoantibodies. By blocking it, belimumab basically cuts off their support system. Then you have anifrolumab. It takes a totally different angle. It blocks the receptor for something called type 1 interferon, which acts like a master alarm, sending the immune system into total overdrive in a lot of lupus patients.
So what does this actually mean for patients in the real world? Well, it means a real, measurable drop in disease activity. It means a huge reduction in those severe, debilitating flares. And, this is a big one, it lets patients cut back on their dose of those damaging steroids. This is not just about feeling better today, it's about preventing serious organ damage down the road.
But here's the thing. That first wave of drugs, they just proved the concept was possible. They showed that we could target lupus with precision. And that has just opened the floodgates for a whole new generation of even more sophisticated therapies.
The research pipeline right now is absolutely packed. We are talking dozens and dozens of new drugs in development, everything from new biologic agents to simple pills, and each one is designed to hit a different, specific piece of this incredibly complex lupus puzzle. The momentum is it's amazing to see.
I mean, the level of specificity we're seeing now is just remarkable. Take dapirolizumab. It blocks the communication between two key immune cells, T cells and B cells, and it's been cleverly designed to avoid the blood clot risks that older drugs had. Or telitacicept, a dual inhibitor. It blocks two B cell survival factors for even tighter control. And then there's deucravacitinib. It's an oral pill that zeroes in on this one specific enzyme, TYK2, to shut down inflammatory signals. It's just so precise.
All right, this next idea is a huge leap forward. So far, we've been talking about controlling or suppressing the faulty immune system. But what if you could just restart it? Like wipe the slate clean and reboot the whole thing back to a healthy state? This question, right here, it gets to the heart of one of the most revolutionary approaches out there: CAR T-cell therapy. This isn't a pill or a simple infusion. It's a form of living medicine, created by using a patient's own cells and basically turning them into super soldiers to fight their disease.
So here's how it works. First, doctors take out some of a patient's T cells, which are a type of immune soldier. Then, in a lab, and this is where the magic happens, they reprogram those cells. They give them a new chimeric antigen receptor, that's the CAR, that specifically targets the bad B cells causing the lupus. These new super soldiers get multiplied into an army of millions, and then they're put back into the patient, where they go on a mission to hunt down and eliminate the source of the problem.
So, the big question, does it work? Well, the initial results have been nothing short of breathtaking. In a landmark early study, they took 5 patients with severe lupus, people who had failed every other treatment. Every single one of them, 5 out of 5, achieved a deep, drug-free remission after getting CAR T therapy.
But honestly, this is the most incredible part. After the CAR T cells did their job and cleared out the faulty B cells, the patient's body started making new ones. And these new B cells? They appeared to be healthy, normal. They were tolerant of the body's own tissues again. This suggests that CAR T didn't just get rid of the disease, it may have actually reset the entire immune system, restoring that immune tolerance that was lost in the first place. It's mind-blowing.
So where is all of this going? What's the ultimate goal? Well, it's pointing straight towards the holy grail of medicine, moving away from a one-size-fits-all approach to something way more powerful, truly personalized treatment.
Because here's a crucial thing to understand. Lupus isn't just one disease. It's incredibly diverse. Heterogeneous is the scientific term. It looks different in different people because the root molecular causes are different. So the future isn't just about finding more drugs. It's about finding the perfect drug for each individual patient. That's the whole idea behind precision medicine. And to make that happen, scientists are building this amazing new toolkit. We can now analyze a patient's genetic risk factors. We can look for biomarkers in their blood. For example, a high interferon signature is a really strong clue that a patient will respond well to anifrolumab. We can even do what's called transcriptomics profiling, analyzing patterns of gene activity to match patients with the therapy that is most likely to work for them.
So we've gone from sledgehammers causing all this damage, to scalpels offering precision control, and now to therapies that can literally reboot the entire system. We are entering an era where treatment is no longer just about managing a disease, but about understanding and fixing it at an individual, personal level. And it leaves us with this really hopeful question. In the near future, could treating lupus be as personalized and as unique as the very person who has it? Thanks for joining us.